What information are we missing? Specific heat capacity. I don't suppose that's anywhere handy, is it?
Yeah.
It is. It's in your textbook, right? 4.19 is your textbook's number. You will do this so many times with water that you will remember that. Online, some of my solutions, bless you, might have 4.18 because that's the value the old textbook had. These textbooks are less than 2 years old. So, don't lose your mind if you see in the math solutions online 4.18. The math is going to be the same. You're going to be off by a decimal place somewhere. Okay, you should still get the same number.
Are we allowed to put 4.18?
Do what your textbook has. Put 4.19. Okay, what are the units on C? Yep. Joule, gram, degrees Celsius. So, you cannot use 1 kilogram. You have to have the same units as your C. You can either change this to kilojoules, kilograms, or change that to grams. How many grams are in a kilogram? 1,000. So you've got 1,000 grams. Okay? Can you solve Q for water now? All right, solve it. The heat gained by the air is equal to the negative heat that the water released. So, whenever you have this boundary, the boundary here between the system and the surroundings almost, right? Like the water is losing the heat, it's going out into the air. So your sign is opposite, but your value is the same. So Q of air is equal to the negative Q for H2O. So negative times negative, is it 838? 00 joules. So now we know the quantity of heat that the air absorbed. What are we solving in this equation? Edmund? Sorry, Evan?
Solving for delta T.
We're solving for delta T. If you are solving for one unknown, you have to know all the other pieces. We now know Q of air because it's equal to the amount of energy that water gave up. We know the mass of air. C is a constant. It's also going to be in the table. Your textbook's not going to ask questions about a substance it doesn't provide you a C for, unless it says research the value, and then, okay, it will be in the table. So now you know mass, C, Q, you can solve for delta T. Okay? Okay. Lexi, is this the number that was in the book? 41.5. Does it make sense that the number for the change in temperature is positive? That's saying that the final temperature of the air is higher than it was initially. Does that make sense based on what you know in the question? Yeah. You always have to ask yourself this. because sometimes you make an assumption and you forget to check whether or not your delta T makes sense. If it went down, your delta T would be negative, okay? You will have potential energy on the side. The higher you are on the y-axis, the more energy. You can have time, or we like to write reaction progress. Okay? So we're going to use number 11 to do our first potential energy diagram together. Says frost forms on the windshield of a car on a cold winter morning. How would you represent frost using chemical symbols? Evan?
H2O with S, solid.
Yeah. So frost is solid water. Okay. It says this frost disappears with no evidence that liquid water forms. Draw an enthalpy diagram to illustrate the change. So what happened to it? It evaporated. Do you remember what we call going from a solid straight to a gas with no liquid? No. Vaporization is a liquid to a gas. Yeah, sublimation. Going from a solid to a gas state, skipping the liquid, is called sublimation.
What was the other one?
The opposite process of going from a gas to a solid is also called sublimation.
Different?
They're not different, to my knowledge. If you have grandparents, you might notice sometimes if they pull out a wool sweater out of their closet, it smells a little funky. Older generations my grandmother used to use mothballs. They'll put mothballs, something you can actually buy at a store, put them in the cupboard or put them in the cedar box, wherever their wool stuff is, because moth larvae love to eat wool. So you'd go pull out your nice sweater and it's just full of holes. Mothballs are made out of a substance that sublimates. So the moth larvae and the moths actually do not like the gas that comes off of them. So it's a bug repellent, basically. I think dry ice. What's dry ice? It's not CO2 solid. It does not liquefy at room temperature. It goes directly to the gas state. So dry ice sublimates. It goes from CO2 solid to CO2 gas. Okay, it sublimates. Now, so if we're going to H2O gas, are we putting energy in or taking energy out? We're going from a solid to a gas. Edmund? Yeah, we're putting it in. So it's an endothermic reaction. So the chemical reaction for this would be H2O solid plus energy produces H2O vapor. Okay? Inside this green box right here is the thermochemical equation for the sublimation of water. So that's a thermochemical chemical equation because it has energy in it. Okay? Thermochemical equation. You can put that into a potential energy diagram. If this is our reactant, if this is H2O solid, we're putting energy in so our product contains more potential energy. Your textbook has two lines that are parallel. Not everybody does it like that. This is a different way to do it. The difference in height here is the enthalpy change to make this happen. Okay? This is the enthalpy change to make this happen. Because it actually looks like a step. You're going up stairs when you're putting energy in. So anytime you have an endothermic reaction, you're going to have a potential energy diagram that looks like that. Yeah?
So do you want us to do them like that or like the textbook?
You can do it like the textbook if you want, but I think this one's a lot clearer.
The textbook has less lines in it.
Does it though?
It doesn't have a bottom.
If you have an exothermic reaction, energy is being released. So your reactants are higher than your products. Energy was released, so your reactants have a higher potential energy than your products. The difference is the enthalpy change. That's the energy that is released. So this is exothermic. Now think about a long set of stairs. Is it easier to go up or is it easier to go down? Go down, right? You need to put more energy in to go upstairs. So this is why I like doing diagrams like this. Two ways to write thermochemical equations. Then you have molar enthalpy. And then you have potential energy diagrams. Do you want me to use the same example that they used in the book, or do you want me to use a different one?
Different.
All right. So we're going to do... Okay. I'll do easy ones. Okay. When you're given a question that says, represent this enthalpy change the 4 different ways, you have to be given enough information, or you actually have to be given one of these. You have to be given something. Okay? You have to be given one of them. All right. Do you know how to write a combustion equation? Okay. No? Okay. We're going to assume complete combustion. Okay? We're going to keep it simple. Okay, Lexi, pick a number between 1 and 8.
2.
Okay, thank you. Okay, so we're going to do we're going to represent the information 4 different ways for the combustion of ethane. Okay, so we're going to do the combustion of ethane. What's the chemical formula for ethane? I get a little nervous when you don't know this. Christian? C2H6. When you write a combustion reaction, what is your other reactant? Sorry. O2. Because I said we're assuming complete combustion, what are our 2 products?
Carbon dioxide and water.
Carbon dioxide and water. Now, I'm going to use a value from table 5.4 on page 295. And it's got bolded and starred at the bottom of it. It says note. So they actually want you to pay attention to this point. Because they are standard values, meaning reactants started at 25 and the products end at 25, the products are H2O liquid and carbon dioxide gas for the values in their table. You have to pay attention to what the enthalpy values are. You can go online and Google what's the enthalpy change for the combustion of ethane, and you might get a slightly different number. It might be off by 44 kilojoules. But it depends whether they have H2O gas or H2O liquid in their answer. You will get a different value. Okay? We'll get into why a little bit later. But this information that they're giving here in the table is telling us what states to put in our chemical equation. States are really important in this unit, okay? So we form CO2 gas and H2O liquid. So I want you to balance that. 2, 7, 4, and 6. You got it. All right. Have to start with a balanced chemical equation. All right, table 295 happens to have what? What does it give us? What does it mean when you have something, when you have a delta H and then there's a subscript and a couple of letters? Talked about it yesterday. Put another word in front of what you just said. M. Molar enthalpy of combustion. Okay, so they give you the molar enthalpy of combustion for ethane. And it is 1560.7 kilojoules per mole. Per mole of what? Christian? Per mole of ethane. So, what does this tell you? Do we give off quite a bit of heat or not very much heat? What do you think about this number, 1,500? It's a nice number. It's quite a bit of heat for a pretty small molecule. Okay. What does the negative sign tell you? Yeah, heat is given off. So is it endo or exo? It's exo. You getting this? It's exothermic. So energy is released. So we can change our chemical reaction into a thermochemical reaction by putting our heat change for this reaction in the chemical equation. Which side will it go on? Nimra? The right-hand side, because energy is produced. It's another product, okay? When you put it in the chemical equation, there is no negative. The negative tells you which side it goes on. You just put plus, like it's another product, and then the amount. So make your chemical equation into a thermochemical right now. That coefficient of 2 says in this chemical equation 2 moles of ethane react with 7 moles of oxygen to produce 4 moles of CO2 and 6 moles of liquid water. So we also have to double our energy. So it is
3121.
kilojoules. Okay? This goes on the right-hand side because it's exothermic. You have to take the molar enthalpy and multiply it by the actual number of moles, the coefficient in the chemical equation. The other way to write a thermochemical equation is to put a delta H at the end of your chemical equation. This one, it's in the chemical equation. The second way to do the thermochem is to actually put a delta H at the end. So you would write 2C2H6 plus 7O2 goes to 4CO2 plus 6H2O, and my delta H is equal to negative 3,121.4 kilojoules. Your delta H goes on the end. You have to put the negative sign in to indicate that it's exothermic.
You could just do plus.
You can put the plus if you're putting it in the thermochemical equation as a product.
Would I ever ask for one or the other, and can you use either one at the time?
Yeah, if it says write a thermochemical equation for this, you can do either one. But if I say, here's some information, represent it 4 different ways, you have to do both. Okay? If I say to you, represent this information 4 different ways, 2 of them are going to be thermochemical and they're going to be different. If a question asks you to put information in a thermochemical equation, you pick which one you want. I don't have a preference. Okay? So now you've got 3 ways. You've got thermochemical equation 1, thermochemical equation 2, molar enthalpy. The last thing is a potential energy diagram. So your potential energy diagram, label the axes. It's exothermic, so are we going upstairs or downstairs? we're going down. So our reactants have a higher potential energy than our products. And then you put in your actual so there's your potential energy diagram for this reaction. Okay? All right. Nitrogen plus hydrogen gas produces ammonia. This is a very important industrial process because ammonia can be used to make so many other products. And it releases 92.38 kilojoules for every mole of nitrogen gas converted. Represent this information the other three ways. The other three ways. If you don't know what to use for the subscript for your molar enthalpy, you can put X. Austin?
Yeah, you put delta H equals negative.
Yeah. You put, thank you, negative 92.38 kilojoules. You do not use kilojoules per mole in your thermochemical. Just kilojoules, okay? Just kilojoules. The only time you have kilojoules per mole is for a molar enthalpy. What else did you do? Probably did the potential energy diagram. Is it a step up or a step down? Step down. Can anybody tell me what kind of a reaction this is? What kind of a reaction is it? Synthesis. We're forming what substance? Ammonia. So we could write a molar enthalpy for the formation of ammonia. Right? We could do a molar enthalpy for the formation of ammonia. You could do, because I didn't specifically tell you what your delta H should, your molar enthalpy should be in respect to, right? That wasn't asked in this question. If you did delta HX for N2, what would your value be? If this was just for N2 in this reaction, what would your value be? Evan?
Negative 92.38 kilojoules per mole.
What would it be if you did it for ammonia? If we did it for the formation of ammonia? Edmund?
46.16 kilojoules per mole.
Do you understand why these two numbers are different?
No.
Awesome. What is the coefficient here in front of the 1? 1. Sorry, in front of the N2. 1. What is the coefficient here in front of the NH3? 2. So you take your total enthalpy change for the second one here, and you divide by 2 moles, because it's per 1 mole. So you always take your total energy and divide by the coefficient in front of that substance that your molar enthalpy refers to. So thank you for saying no, you didn't get it. Okay? You want to do another one?
So we rate them both?
Just one. Okay? Represent that information 3 other ways. 66.4 kilojoules. Sorry, that's a kJ at the end. Or you're going to write N2 plus O2 plus 66.4 kilojoules. Makes 2 NO2s. Okay? No. It doesn't matter what order as long as it's on the left. Guys, don't pack up yet. And then your potential energy diagram. Are you stepping up or stepping down? Up. Reaction, RXN. Okay, homework. You are going to do 7 through 12 on page 295. Yeah.
So you know how like this one is kind of like off to the side? Yes. Since it's on the left, would it be written on the left or would it still be off to the
Still on the side.
Latina, full stop, in the office, please. Latina, full stop.
Now I wasn't lost in this class. We're probably gonna come again tomorrow, so I don't get lost again.
You good?
So I'm leaving next week.
Yeah.
Just down school with me.
Yes. And I will post the textbook pages. Like I'll actually scan the textbook. It doesn't come out great. Like the old, you remember the grade 11 textbook? It had nice PDFs. Because it's photocopied, the light goes through the page. It's never clear. Okay? But that way you don't have to take your textbook with you.
What pages are we reading? Just
By
will
then,
we be continuing?
we're gonna just keep going.
So could I take pictures?
Sure you could.
Of the pages?
Yeah. I'm gonna do that, that's even better.
That way I have.
Because the answers I know are already posted,
Okay.
okay?
And then you won't be finishing up this unit before I get back. That's gonna be a while. Thank you.
You're welcome.
In the questions, it says HI. Would that be HGI? Is that mercury? For like the first question, it says HI plus like KCl equals. It just says H.
H and I,
Yeah.
so hydrogen iodide.
Oh, I'm so stupid. Why did I think it was? What am I doing?
I don't know.
I don't know what these are. Someone gave these to me, but you might want to identify these. I have no idea what these are.
What did they do? They just said, here, buddy, take these?
Yeah, I know. In my set.
Who
They're
gave
like, are
them
these
to you?
mints? That's what they said, and I'm just like, I don't know what these are.
Who gave them to you?
I don't know. Who's his name?
You don't know who he is?
No, it was with. I mean, like, they're probably not bad, but I just don't know what they are.
You're smart. You don't take anything that somebody else gives you, especially if you don't know that person, right? You don't know if that's acid. like LSD acid. You don't know if it's
The
ecstasy.
kid had 2 in his mouth. I was like, what do you?
It could
be anything.
They could be mints.
It could, but the chance you're taking on that is,
Yeah,
know,
not worth it, eh?
not really worth.
Not really worth
Fresh breath really isn't worth the psychoactive effects of
it. Yeah.
LSD or
Yeah.
ecstasy or something like
Yes.
that.
But
Are
you
you just
don't
gonna
know.
dispose of those?
Yes.
Okay.
Do you know who the kid was?
No, I think they're probably mints. I just didn't want to take any chances, you know.
That's funny.
Yeah.
That's really funny.
I
No.
was like, man, maybe I can test these for something. Like maybe I can do some chemical tests on them.
Yeah, I wouldn't have anything here at school that I could test these with, but
Yeah.
that's, I'm gonna ask
Weird.
the police liaison officer if he has something. They must have something,
To
with the
test
kit that they
substances.
just drop it in, add a liquid and,
Oh, they do. There's like this when they do border security. They have this substance. I don't know what it is, but if you drop it could be like anything from methamphetamines to opium, but it gives you a color based on what the substance
yeah,
is.
yeah.
Yeah, it's pretty cool.
That's cool. How do you know that?
Border security shows. You know, teaches you a lot about how they identify things going over the
Oh,
border.
the
that are-
TV show?
Yeah.
Yeah,
It's
okay.
pretty cool.
That is pretty cool. I always feel bad for the people that get caught.
What?
Whether, I do.
You do?
I do.
Bad?
I feel bad that they're so
Some of them
stupid.
are. Some of them are like you see the ones like Colombia. Some of them are drug mules, so which isn't good.
Yeah, and they don't, half of them don't even know.
Yeah.
Or their family has been threatened in some way. Yeah,
Yeah, that's-
totally.
Okay. I
Such
just
a-
wanted to.
Okay,
I was like,
thanks.
I wanted to ask about the questions, but I was also like, you know, maybe like.
Yeah, thanks. Hi.
Okay, yeah, I'm having a little bit of trouble with this, so can I
Okay.
come in at lunch to talk about it?
Yeah, do you want to talk now or are you in a rush?
Someone's out there waiting for me.
Okay.
So, yeah. I wanted to talk,
Did
but I
it-
told him like
Did
I
it
kind of
help?
want to talk. Did this
Did
help?
today help?
It helped a bit, but I'm still having like a bit of trouble with it.
Okay.
So
Okay, so try the homework,
okay,
check your answers, and then highlight the one that you didn't get the right answer for.
okay,
Okay?
okay,
And we'll go through it like that. We'll approach it with the actual questions.
okay.
Okay?
Thanks.
Good luck. You're welcome.